Okay, hello. So आज वापस से एक और stream on one more thing. But यहाँ पे probably we are gonna be doing something new on binary trees. Let's see what we're gonna do. So it is check for balanced binary tree. कल तक किया we did maximum depth in binary tree. Let's see if the stream is working or not. So I go to my account. Why is the net slow, bro? Okay, fine. View channel, view live. Yeah, okay. It is working apparently. Okay, so let's go with this. But first, my thing is that I wanted to know that maximum depth I did BFS. Wait, what did I do was basically I went through whole thing and I was increasing count on the BFS. I'm pretty sure there's a function of height also if I'm not wrong. So what are they doing it? Wait, they also doing BFS. Come on, if it's a BFS, then it's the same thing. So we are initiating a queue and we are going through the height. Okay, then it's the same thing. Okay. Now they want us to do balanced binary tree. It's supposed to be easy only if you know the algorithm. But okay, so given if a tree, determine if it is height balanced. So it is a root 3 9 20 null null obviously 3 9 20 null and null 15 and 7. So we have to determine if the root is balanced or not. So if root is equals to null, it is true that it is balanced. Edge cases, please. Okay. Hmm. How do we know if it is height balanced? Hmm. Can we have a function which returns the height? Okay. Can we have a function which returns the height for a value? So suppose if you go down, the value should be going, height should be increasing, right? Okay, so int left one is equals to height which goes root dot left. Let's see. I'm pretty sure if there can be a function which can अगर हम लोग height पता कर लेते हैं तो if root dot left is equals to null and root dot right is equals to null, return 0. That means there is nothing. If root dot left return root dot left height plus 1. If root dot right return root dot right height plus 1 and return height. I hope this works. Oh wait. Return false. See out left one. Okay, let me see. So for this thing, the height should be 1 0 1 2. Left one is 0. Okay, left one is 1. No, something is wrong. Okay, so ये function call हुआ and it went to left or it went to right. If it's possible, it went to left. It went to left. Now it's not possible to go right or left. So it was returning this. Turn this value. Okay. Left one is equals to this. Right one. Why am I even writing this? I'm writing. Return maximum of left and right. Come on, please, Sayoda. If it is correct, oh, so it says that it's not a type. If root dot left not equals to null. And left is equals to 0. Right is equals to 0. Ah, does this work? It is not working. है. So, hmm, height is 0, right? I've given the value of height as 0. This is 0. 0 था ये value. If root का left नहीं है, then go to left. And if नहीं है, okay, here the value. So for this one, the value if root ka left is null and right is null, so we're returning 0. Return 1. You know what? Return 1. No, that's not how it will be done. So suppose this returns 0 to this person. This also returns 0 to him. But for me, I have to return 1. And I am a person who has one height. Okay, इसके हिसाब से the height is 2. This is returning 0. This is returning 0. And he will return 1. He will return him 0. He returns 0, 0, 0 or 0 आया for him. He will take one of those values and he will return 1. For him, suppose if he returns 2, or if he returns 1, no, he should return 1. So suppose yeah, he returns 1, he returns 1. He takes the maximum value, returns 2 to him. And he returns 1, so he takes the maximum of left and right. And he will return those. So why are we adding the parameter here? Something is wrong. What if we are not calling it by reference? No. You know what? I'll just take it. Nope, that is not the reason. No need for reference. Yeah, it's supposed to be an easy, right? Why am I getting stuck? Okay. You know what? Give me right one also. Hmm. Left is 1, right is 1. What do you mean? Left is 1, right is 1. Come on. Right is 1. Right has one depth. Left has like 1, 2, 3, right? Why are you not giving me 3? Why are you giving me 1? What is the problem? Okay. Okay, suppose think. Okay, function calls. This one function means if root left is null and right is null, we are returning 1. So suppose we go here. This one will return 1. This one also returns 1 to him. This guy gets 1 from both sides and he will take the maximum of those depth and he will return it back to that person. So that has been called. He will take the maximum of all those values and he will return it. Suppose if he got 0, he will take both 0 and he will return 1. He will be taking those and he will return 2. But the depth is 3, so let's just return 1. Okay. If root dot left is not equals to null, left is equals to root dot left and height. If root dot right is not equal to none, we call the root dot right and again the value of height. Same value of height has been passed. What is the problem? I have no idea. Why do we need height? We don't need this value, right? I don't think we need this value. Hmm. Oh, my bad. We still have to call the function. Wow. Now it is working. Let me see why it was not working. Okay, I was never calling the function. So dumb of me. Okay, okay, okay. Okay, my bad, my bad. Then left double equals to right. I think they should solve it. I hope this solves it. Ah, there is always something that doesn't work. Because let's see. According to him, left is 1, right is 2, and the output is that it is true. Why is it true? What do you mean by height balance? Height balance is a tree in which the depth of the two subtree never differs by more than one. What do you mean? Height balance is a bind tree in which the depth of the two subtree of every node in which the depth of the two subtrees of every node. Oh my god. What do you mean? What do you mean? Is it question is written very badly. Trust me, bro. I can't understand what this question is trying to say at least. A height balance tree is a binary tree with the depth of the two subtrees of every node differs by more than one. Uh, what? What does it mean? What? Just tell me what does it mean? A binary tree is balanced if for all of its node the difference between the left and right subtree height is not more than one. Okay. So for this, the height of this and this difference should not be more than one. So what? How many parameters are there? 0 to 5000. So that basically means we can do this calculation, this function call for every time. So what we're gonna do is bool true happens is equals to true. We are gonna create a queue of tree node star. We're gonna name it queue. We're gonna push root there. See, the reason why you can brute force is, first of all, an easy tag. Second of all, the parameters are in 5000, so basically 10 to the power 3. It can take approximately more than n squared time complexity. Anyways, so we can do the whole iteration. Like one single iteration will be n, and for every iteration we are then reiterating it. So n squared basically. So while q is not empty, what we are gonna do is we are gonna get the size and we are gonna run a loop for the size. What do we want? Okay, we get this. We call okay. Hmm. Uh, Tree node star temp is equals to q dot front q dot pop. We took it. We popped it. If temp dot temp left q dot push temp to. If temp right q dot push temp right. Okay, and what we're gonna do is int huh bool check if balance is balanced Is the function call is balance? Oh my god, we have a function called balance. It's custom balance for our temp. If not, if not balanced, return false. If it always passes the parameter, return true. The function is called bool is custom balance tree node star root. What you're gonna do is int left is equals to, if root is equals to null, then we return that it has no height. Int left is equals to height of root left. Int right is equals to height of root right. If right absolute of left minus right is less than equals to 1, return true, return false. Please work. I've thought about it for so long. Ah, yeah, very good. There will be always something wrong. I'm not this time, it's not. A big one. There is nothing called is empty. There is one error is generated. Dot is empty. While Q is not empty. That is what I'm trying to do. What do you mean it's wrong? Hmm. While Q dot is empty. Oh wait. Do we not have this? We have this. Q dot is empty. Um, Q dot push pure empty. We have while Q dot not empty. That's all. Okay. We have an error here. So it says we are accessing a null pointer somewhere. Line 15. Okay, we are accessing null pointer here because root itself being passed here is null. So wait. If root is equals to null. I was never assuming we'll pass a null, but sure. Okay. Wait. If root is null. My bad. If root itself is null. Please return true, sir. Okay. Oh, it works. The logic was correct. It works with the best time complexity? What do you mean? Oh, first question I brute force it out. Sure. Okay. The question is called diameter of a tree. We are not going to solve it this time. Oh wait, I have already solved it before. What do you mean I have already? Oh wait, I don't have the solution with me. I don't want to see my submissions. There will be somewhere. I want to see. Let's see. Given the root of a tree, return the length of the diameter of the tree. The diameter of the tree is the length of the longest path between two nodes in a tree. This path may or may not pass through the root. So I am pretty sure you might be expecting a n-square time complexity here. It says that it needs the longest path, and the path might or might not go through the. Okay, we'll be solving it in the next stream. Enough for today because I have other works. See you guys